inoperable list.
What's up, everybody? Let's keep going. I hope you're still tuned in. I'm going to try to get this over before too late, okay? But we have meetings today. See if I can catch up to you guys. So we're going to study right now arc length, okay? And I'm going to give you the arc length formula first thing, because I know you guys are pressed for time. So here we go. We got x degrees over okay. So how about this? We're going to put the measure of our central angle, okay, divided by 360 times 2r pi, okay? So we're going to find the measure of our central angle, okay? I've been kind of symbolizing that with my students in a shorthand formula where we've just been writing this, okay? We've been writing x, and we kind of know that the x stands for the measure of the central angle, but I'm going to share that with you because maybe you don't know that. So here we go. What is the measure of our central angle in this case? We're trying to measure the length of this arc that's in bold, right? Right here. And so if it was the whole circle, it would be nice and easy to just use this formula that we just learned in the last video, right? However, this is not so pretty because we have only a portion of the circle, okay? 225 degrees of the circle. The whole circle, right, if I took the red and the blue, should add up to 360. So that's where this comes from. We're trying to find out what proportion of the circle are we getting. What proportion of the arc length, okay? If we're taking the whole thing, we would be taking 360 degrees of it, and 360 divided by 360 is 1, and then we would be stuck with the same circumference formula that you get because 360 degrees is the whole circle, all right? Well, in most cases, you're not going to have to do that. If you're studying arc length, you're not using the circumference formula. You're going to just use part of the circle. So in this case, we're going to plug in 225 into this formula right here, okay? But let's back up and get more space. So like I said, our formula is going to be arc length equals our x degrees over 360 times 2r pi. So first we put in for x, we're going to put in our central angle. And what is our central angle? It's 225. So instead of writing x this time, what are we going to write? 225. Okay? 225 degrees over 360. So me and my students have been debating what's the best way to do these problems. I would say go ahead and pop this into your calculator right now. It's the quickest way to get a feel for what's going on, okay? So we're going to put into our calculator 225 divided by 360. And I get 0.625, okay? You could reduce the fractions and do this a lot of different ways, okay? But go ahead and just pop that into your calculator and then get the value in the next step. So how much is our radius? In this case, our radius, let's look for it. The center to the edge, that's the radius. The radius is 12, right? That's our radius. So for r, I'm going to put 12, all right? So 2 times 12 is 24. So I can see I got 0.625 times 24 pi. So now all we have to do is do 0.625 times 24. So go ahead and put in your calculator 0.625 times 24. And you should get 15. Okay, 15 pi. And what are we going to write for pi in this case? I like finishing the first problem all the way. So instead of pi, what do I write? Let's change it for 3.14. Okay, and so what's 15 times 3.14? You should get 47.1. Okay, let me move this out the way. So you should get 47.1 centimeters. Okay, so that means that maybe the whole circle, right, is going to be 12 times pi, so it would be a little more than 36 centimeters around. Or what do we got now? 12 times 3.14. So the arc length that we have right here, instead of being the whole circle, just this red piece right here, is 47.1 centimeters long. Okay? Double check our work right there. Okay, cool. So, that's the way you do these problems. Let's try the next one. Okay, it gets easier to kind of visualize when you see that. In this case, we have arc length equals x degrees over 360. It's a good idea to write this formula every time when we do these problems. That way you won't forget it. So on top of 360, this time I'm going to put the measure of our central angle, and that's 90. So go ahead and put 90 right there. And then into the radius, I'm going to put 10. So you could figure out that 90 over 360, this looks like a quarter of the slice. So just so this makes a little bit of sense, it looks like a quarter of the circle. So if I looked at the whole circle, okay, I would have to do 2r, that's 2 times 10, that's 20 pi. And 20 pi is about 20 times 3, so a little more than 60, right? So to go around the circle would take about 60 feet. But this is going to be about a quarter of that, because we're only asking for this portion of the circle. So if we calculate this right, we know that 90 over 360 is going to be about 1/4, all right? You might also want to go in your calculator and check that. If you don't believe me, you're going to see you get exactly 0.25, right? And 25 cents is called a quarter. So 2 times 10 is 20. And then we'll do a quarter of 20. What's a quarter of 20? 5. So we get 5 pi. And in this case, I'm not going to go ahead and do the next step because I want you to get the rhythm for doing this problem instead of the little calculations. So calculate on your own if you have to, but there you go. All right. If you calculate, you should get something like that. A little more than 15. A little more than 5 times 3. So here we go. Let's do arc length. Equals 360 over x to our pi. And in this case, we got 300. Okay, times, what's my radius? 17. So let's fix this. I was writing a little fast, trying to get done here. So we're going to go to our calculator and we're going to punch in 300 divided by 360. Alright, this is a good way to do the problem, especially now since everybody has a calculator with them at all times in their cell phone. So what's 0.833 times 34? We get 28.33, okay? And then pi is, well, pi in this case, I really don't want to bother, but if you want to multiply it times 3.14 for that last step, you should get, right, for 28.33 times 3.14, round to the nearest tenth, you should get something pretty close to 89.0. Okay? So here we go. The next thing on the agenda is going to be, how many more of these do we got? We got a few of them. All right. Let's go to sector area. So I don't want this video to drag on. But actually, look, I'll give you guys some extra practice. We just did that one. Check this out. Go ahead. Pause the video and try to do this problem right now, and I'm going to flash the answer on the board, and you can see if you got it right. But you're going to have to multiply the answer out by 3.14 yourself. So go ahead and check. Did you get it right? Did you get 66.0? That's what you should have got. All right, let's try another one. If you missed that one, go ahead. Go for this one. You could do it. Go. Pause the video and try this problem right here. And the answer is 43.2. All right, I hope you did it right. Let's try another one. Okay, go ahead. We already did one with the 0.25 with the quarter of the circle, right? So go ahead. You should have a nice problem that we did a few problems ago. It's just like this one. Pause it and try it yourself. And if you're back, let's see if you did it right. You should have 14.1 inches. Okay. So now let's go to a new problem. It's a little more complicated just because you deal with the square, but otherwise it's exactly the same. So on top we put x, and x still stands for our central angle, which is going to be the only angle that you even have to concern yourself with. I'm not going to try to confuse you. And we're going to use our formula, r squared times pi. And this is our area formula. So since it says sector area, let's use the proportion of the area of the circle that I'm going to use, right? So if I had 360 over 360, I want to find the whole circle. But in this case, I only have a 30-degree angle. So I need to put 30 on top of 360. And that tells me what proportion of the circle I have. And we can also look to see what's our radius. Our radius is the distance from the center to the edge. So that's 6. And so now we got our 30 divided by 360. We get our 0.0833. And this is times 36 pi. So 0.088 times 36 gives me 2.99 pi. And if I multiply that times 3.14, I get 9.41962. Okay? Feet squared. Okay? Fix that. Okay, so what's sector area talking about? Okay, well, let's try to break our diameter into some pieces. Okay, we'll see that this is about half, right? So that should be about 3 and 3. So let's chop that into thirds and that into thirds. So if I go like this, and like that, and like that, and like that, and like this. Just keep going. 1, 2, 3. And then we got 1, 2. Okay, those are probably a little spaced too close. Alright, I'm probably ruining my video here, but I want just to be clear, okay? So please, if you're suffering through my video, at least let me make my point. So here we go. I'm going to try to have this look. Okay, so we have 6 going all the way across. You with me? There should be a lot more a lot more squares in the whole circle. How many squares are there? If you counted them up, right? If this distance right here is 6, and this is 6, and each square is 1 by 1, how many little 1 by 1 squares are there? Okay? There's a lot more than 9 of them. But if I ask myself, how many of those squares are there in this little sector right here? How many squares are there in here? There's 9.4 of them. And that's what we just did. That's what sector area means. I think a lot of people are kind of confused by it because they don't even get what that is in the first place, okay? So that's why we're measuring in feet squared, because now we're talking about area. We're talking about how many squares could fit inside of this circle, okay? We'll do another problem to get the hang of this. So, go ahead and type in sector area. Type it in. Go ahead and write it. And we're going to do our formula. 360 times not 2r pi. Since we're doing area, we're going to use r squared, and we're using square units now, and pi. And so our angle of our central angle in this case, this angle right here, is 105. And our radius is 14. So if I do 105 divided by 360, I get 0.29167, okay? And then 14 times 14. You get 196 for 14 times 14. Okay, and what do we get after we multiply these two together? We get 0.29167. I get 57.16. Okay, we'll just 167, whatever. And then here we're going to put 3.14. Okay, so if I multiply this number times 3.14, I find out how many squares there would be in this thing. If we're talking about square miles, and if this circle was 14 miles long, that would take you a long time to count those squares. You get pretty tired, okay? Well, we get 179.5 miles squared, okay? So maybe the whole circle has a lot more than that, but this sector, how many squares do we got? All right, if this distance is 14, we have 179 of these squares in our sector that we're talking about, okay? And I know they don't look very squarey, but, you know, come on. How much do you want? It's a pretty low budget here, okay? Let's go. So, next problem. We're going to put our sector area. We got 360 over x, and then we got r squared times pi. I'm going to fix that r, that's a little illegible. So, what's my x? 45. What's my r? 11. So we got 45 divided by 360. We got 0.125. Write that again. I don't want you to think it's negative. We got 0.125 times 11 squared is 121. And we get pi, so I got this times 121 equals 15.125 times pi. And you can go ahead and do your multiplication to find out what you got in there. I'll let the program do it for us, and you should have 47.5 feet. So, I'm going to give you one to practice on your own if you really want extra practice. Go go ahead and pause it and try to do the whole problem by yourself and see if you really learned. If you didn't, I would go back and watch it over again until you really feel like you got it, okay? So press pause, and let's see if you got it, all right? 134.0 feet squared. That's what you should have got. All right, I hope you're happy if you got it. Let's try another one, huh? Try number 19. Go ahead and pause the video. Pause. Press it. All right? And did you get this problem? Should have got 16.5 feet squared. All right. So we got another one, okay? Good luck, guys. Press pause and try it on yourself. And this time you should get 461.8 yards squared, okay? So now you should have a feeling if you actually believe that you know what you're doing is right. So good luck on the test, and I'm going to upload these as soon as I can, guys. Sorry it's so late.